Hello, all right, so today is going to be the last section of notes for the whole semester. So last section of notes before the break. All right, so if you look, we're going to talk about angles, so angle of elevation and angle of depression. So if I say angle of elevation, that means I'm standing below something and I'm looking up. So that's looking up. Angle of depression means I'm looking down. So these are all 90-degree angles here. So what do you notice about the angle of elevation? So like this boy is looking up at the girl. This is her angle of depression that she's looking down at him. He's looking up at this angle of elevation. What do you notice about those two? What does that little symbol mean? That means they are the same. Which is going to be useful in a couple of these, one or two of these examples. All right, so example one. So this is pretty much just all the stuff we learned in this unit, especially recently, but now in word problems. So suppose your school is building a stage. The stage will be 30 feet long. So whenever you get a word problem in this unit, it helps to draw the picture. So it's going to be 30 feet long from the front to the back with a total rise of 2 feet. It needs to have an angle of elevation of 5 degrees or less. So it goes up 2 feet. That's not a very straight line. So we need to figure out if this angle of elevation here is 5 degrees or less. So if they're using these two dimensions. So if I'm looking at this angle, this is the hypotenuse because it's 90 degree angle. So the hypotenuse is always opposite of the 90-degree angle. So here are the two legs. If I'm talking about this angle, this leg is adjacent because it's touching the angle, and this one's opposite. So we know they have given us the opposite side and the adjacent side. So what trig function do I want to use? So what uses O and A? So towa. That would be T. T uses O and A. So tangent, I'm just going to call this X. Tangent of X is equal to the opposite over the adjacent, 30. So I got to figure out what X is. So I need to get rid of this tangent. So to get rid of a tangent, I take the inverse tangent of both sides. So now I have X is equal to the inverse tangent of 2 over 30, or you could reduce it to 1 over 15, doesn't matter. So 2 over 30, and then inverse tangent. So I get X is about 3.81 degrees. So is 3.81 degrees 5 degrees or less? Yes, it is. So that means the answer to this question would be yes. Those dimensions would work for this stage. Example 2. From a point 80 meters from the base of a tower. So we got our little tower here. And somebody is standing 80 meters away. So 80 meters away. They're looking up at an angle of elevation of 28 degrees. So we want to know, how tall is this tower? So this is a, oh man, did not mean to erase that. So this is a 90-degree angle right here. So I know if this is the 90-degree angle, this has to be the hypotenuse. And these are the two legs. So if I'm looking at this angle, 28 degrees, X is the opposite, 80 is the adjacent. So I know the opposite and the adjacent. So which trig function uses O and H? So hopefully you said tangent. So the tangent of the angles, tangent of 28 degrees, is equal to the opposite divided by the adjacent. So in order to solve for X, X just needs to being divided by 80. So if I multiply by 80 on both sides, 80 divided by 80 is 1, so now I'll just have x, which is what I want. So 80 times tangent of 28. So tangent of 28 times 80 equals about 42.54 meters. And that's how tall that tower is. Moving on to the next page. So we got a ladder that's 20 feet long leaning against the side of the building. So here's our building. Here's our ladder. It's 20 feet long. If the angle formed by the ladder and the ground is 75 degrees, so here's a 90-degree angle, this is 75 degrees. How far is the bottom of the ladder from the base of the building? So it's asking for this distance right here. So the bottom of the ladder to the base of the building. So this is x. So we have information about two of the sides and this angle. So if I'm using this angle, the opposite side of the 90-degree angle is the hypotenuse. These are the two legs. So this leg is it the adjacent or the opposite of this angle? It's adjacent. So I know the adjacent and the hypotenuse. So I'm using a and h. Which trig function uses a and h? Hopefully you said cosine. So cosine of 75 degrees, or cosine of the angle, is equal to the adjacent divided by the hypotenuse. So x is almost by itself. I just have to multiply both sides by 20. So then I'll have x by itself. On the left side, I'll have 20 times cosine of 75. So if I take the cosine of 75 and multiply it times 20, I'll have x is equal to 5.18. Did they give us units? Feet. So 5.18 feet is how far the ladder is away from the building. The example 4. So Bob's on top of a 60-foot building. So here he is up here. He's looking down, sees his car over here. It looks like a dinosaur. That's a beautiful drawing of a car. So he's looking down, the angle of depression that he looks down. So he's looking over this way. This angle right here is 8 degrees. What is the horizontal distance between the building and his car? So this is a 90-degree angle. So this is where that little piece of information up here comes in handy. What do you notice about the angle of depression and the angle of elevation? They are the same. So if he's looking down at an angle of depression of 8 degrees, that means the angle of elevation that the car is looking up at him is also 8 degrees. So this is a 60-foot building. We're trying to figure out the distance from the building to his car. So this is the angle we're focusing on, because we only want to use angles that are inside of this triangle. The only reason this is helpful is it just helps us find this angle right here. So this is the hypotenuse. We do not have any info about the hypotenuse, so that means we're using the two legs. So which trig function uses the two legs? Or the opposite and adjacent, SOHCAHTOA, so that would be tangent. So tangent of the angle, so tangent of 8 is equal to the opposite, 60, divided by the adjacent, x. So when x is on the top, I can just multiply both sides by the denominator, but if x is on the bottom, I'm going to have to cross multiply. So 60 times 1 is 60. X times tangent of 8 is just x times tangent of 8. So now to get x by itself, because that's my goal, I divide by tangent of 8 on both sides. So x is going to equal 60 divided by tangent of 8. So 60 divided by tan 8. Try that again. Yep, I guess it is. So 426.92 feet. So that's how far away the car is from the building. In example 5, so a couple more. Got a flagpole. Here's the flagpole. It's 42 feet tall. On a sunny day, the flagpole casts a shadow of 20 feet long. So its shadow goes about that far away, so that's 20 feet. It's a 90-degree angle. What is the angle of elevation of the sun at that moment? So if you were standing right here at this spot, and you looked up and the sun was right there, it's casting the shadow. So this is the angle of elevation that we're looking at. So angle of elevation is pretty much always going to be on the ground. So we never use the 90-degree angle, so the only choice really is this angle. So if I'm trying to figure out what x is, first we got to know what sides we're using. So this is the hypotenuse. We're not using the hypotenuse. We don't have any info about the hypotenuse. So we're using the two legs. So the opposite and the adjacent. So again, we're going to be using tangent. So the tangent of the angle, so tangent of x, is equal to the opposite of x, so 42, divided by the adjacent, 20. So you don't have to reduce that, but if you wanted to reduce it, it would be 21 over 10. So I want to get x by itself, so I need to get this tangent out of here. So to get rid of a tangent, I got to take the inverse tangent of both sides. So I'll be left with x is equal to the inverse tangent of 21 over 10. So on my calculator, 21 over 10. I take the inverse tangent. So x is going to equal 64.54 degrees. So that's about how many degrees you'd be looking up if you're standing at the end of that shadow. And then finally, example 6. So Kurt leans a 20-foot long ladder on the side of his house. Oops. So here's the side of his house. His ladder is leaning up against that. Let me try that again. So the ladder is 20 feet long. The ladder reaches to a height of 18.9. So this height from the ground to where the ladder touches the house is 18.9. And the ground and the house form a 90-degree angle. So what is the angle of elevation of the ladder to the nearest tenth of a degree? So again, angle of elevation is pretty much always on the ground. So I'm going to be looking at this angle. So what two sides have they given us? So this is the hypotenuse, and then these are the two legs. So the adjacent leg is right here. The adjacent leg is the one I don't know, so I'm using the opposite and the hypotenuse. So which trig function uses O and H? So that'd be sine. So SOHCAHTOA. So sine of the angle, so sine of x, equals the opposite over the hypotenuse. So if I want to get rid of sine, because I'm trying to get x by itself, I got to use inverse sine on both sides. So I'm left with x on the left side, which is what I want. On the right side, I have inverse of sine of 18.9 divided by 20. So 18.9 divided by 20. So x is equal to 70.9 degrees. And that is it.